Assalamualaikum, my name is Nurul Umairah binti Salam. I'm Matric number 1213037. Today I will present to you about my topic, that is the causal effect relationship between money supply, GDP, government expenditure on inflation. Firstly, I will explain about the introduction. In the realm of economics, inflation stands as a pervasive force exerting its influence on the purchasing power of individuals, the stability of financial market, and the efficacy of macroeconomic policies. Inflation is the rate at which prices rise over a specific period. A research from Honor states that a high inflation rate indicates that the cost of the substance will grow. Still, lower inflation slows economic growth, eventually leading to a recession and a high employment rate. Nonetheless, Moody and Manso in 2019 argued that lower inflation is necessary for economic progress. Furthermore, there are many economic indicators that can influence inflation. One of the well-known indicators of inflation is money supply growth, which is all the currency and other liquid or illiquid instruments in a country's economy. Honor also stated in her research that when the money supply gets too large in relation to the size of an economy, the currency's unit value declines. In other words, its buying power falls and prices rise. After that, inflation and gross domestic products have a causal relationship between them. As we know, inflation may rise as GDP rises due to increased demand or decrease in supply. However, with an increase in inflation, the buying power of money falls, reducing consumption and GDP. Not only that, the government expenditure also will affect the inflation, as the higher the government expenditure will make the inflation becomes higher from the theory. Hence, the determinants that have been chosen are crucial, and many researchers provide some evidence about these variables. So this presentation will show you how to model the vital determinants of inflation and how can we describe the relationship between one or more variables by using order as estimators. This video also focuses on the effect of the economic indicators such as money supply growth, gross domestic product, and government expenditure on the inflation rate towards 63 chosen countries all around the world. Next is literature review. The choice of the model-specific independent variables is deeply rooted in existing literature. Some research has also been done that also look at how those variables can affect the inflation in a country. Aftakhari Mahabadi and Kiai in 2016 made research about the relationship between money supply and inflation, which they suggested money growth appears to be one of the most important factors of global inflation. This study picks up Friedman's famous statement that is, inflation is always and everywhere a monetary phenomenon. Not only that, the research from Rabiul Islam in 2017 stated that there is a positive relationship between inflation and money supply. The statement is parallel to their result of their research when there is a positive correlation between them. According to Dawiher and Heffer in 1988, inflation and money growth have a positive correlation. The connection between these two instruments is determined by money supply and demand. A research from Najihah Yusof in 2021 stated that in Malaysia, the exchange rate and employment rate and government expenditure all had a role in anticipating inflation. The conclusion is consistent with the findings of Cheng and Tan in 2002 and Aurangzeb, who found that government spending and the currency and also an employment rate all have a substantial influence on inflation. After that, Mooney and Manso showed that the influence of the inflation rate on economic development is negative in high inflation situations, but may be positive and more substantial in low inflation conditions. It means that both high and low levels of inflation can have a positive and negative influence on the economy. Lastly, Kandel and Morsi in 2009 investigated the factors influencing inflation in Gulf Cooperation Council countries from 1970 to 2007. They discovered that the major trading partners' inflation rate is the most important determinant in both the short and long run. Okay, for the next part is data description and methodology. The data mentioned in this section and deal with in the model estimation are all taken from the World Bank data website for all available data countries during 2021. The data set at hand includes three interesting independent variables related to inflation. Firstly, money supply growth that we noted as money soup, gross domestic product (GDP), government expenditures, government ESP, and inflation rate as our dependent variable. Okay, for the next part is, the estimation that will be used in this research is by using multiple linear regression model, which allows a clear statistical inference about the world population. Hence, 62 random but the same countries for all explanatory variables have been taken from the dataset in World Bank official website. As stated above, this paper is basically discussing about the effect of money supply growth, we know as money soup, gross domestic product (GDP), government expenditure (GOV/ESP) on inflation rate (Y) for the 62 countries. Hence, the equation is Y is equal to B0 plus B1 money soup plus B2 GDPR plus B3 government ESP plus error term. After this, I will define all of the variables and the units that we used in this model. Firstly, money supply growth, we know as money soup. The money supply is the amount of all the currency and other liquid asset in a country's economy at the time the money supply is calculated. So the money supply comprises all cash in circulation as well as all bank deposits. In this model, the data that has been used for the World Bank database is broad money growth rate and the unit is annual percentage. Okay, Next is gross domestic product, GDPR. GDP quantifies the monetary worth of final products and services that those purchased by the final user produced in a country in a specific period. From the World Bank database, we took GDP growth rate data and the unit is annual percentage. Thirdly, government expenditures, GOVESP. Government expenditure refers to the money spent by the government on products and services such as education, healthcare, social protection, and defenses. So the database that has been taken in is from General Government Final Consumption Expenditure, and the unit is current US. Since the amount of expense for each of the country is big, so we add natural log in this model. After that is inflation rate. The inflation rate, as mentioned by the change in the CPI, indicates the average rate of growth in the price of a basket of goods and services. So the World Bank database that are taken is inflation, which is measured as rate, and the unit is annual percentage. Okay, after that, for chapter 4, that is result, we will start with descriptive analysis, that is measures of central tendency. So the measures of central tendency such as mean, median, and mode for all the variables are shown on the screen. When comparing for all the variables, the highest mean and median goes to non-government ESP, that is 23.6642 and 23.5023. So since the unit for the data available is in the US dollar, while the lowest value of mean and median is GDP, which are 6.28779 and 5.75737 respectively, as it is measured as rate in this model. It indicates that the value for non-government ESP has high expectation compared to GDP. Furthermore, since there are no repeating values or frequency in each of the variables, hence the mode is not available for all the variables. Okay, next, the last part of descriptive analysis is variability and the shape of the data. Variability of the data can be measured by justifying the variance and standard deviation and also range. As we can see from the table above, the variable that have the most variability is money supply, because the standard deviation for the variable is 17.185 and the variance is 295.32. So not only that, money supply also have the highest range among the variables, and it makes sense because the higher range will usually generate higher chances of variability. Besides, the lowest value for standard deviation, range, and variance is non-government ESP. So it is because more data values from the variable is close to the sample mean, and it will make less spread out and less variability. So after that, the shape of the data can be determined by skewness and kurtosis. As we can see, all the variables are positively skewed or skewed to the right. We can justify it by looking at the values of mean and median, since all the mean variables is greater than its median. So the highest value of skewness is in this inflation, which is 6.47749, and the lowest value is non-government ESP, which is 0.21595. Besides, kurtosis for inflation also is the highest too, that is 46136, and it indicates that the shape of the distribution may be very peak, as the greater the value of kurtosis, the higher the peak. Not only that, data sets with high kurtosis also tend to have heavy tails or outliers. If you compare it to the lowest kurtosis, that is non-government ESP, which has 0.19406, so the variable might have fewer tail data and appears to push the tails of the bell curve away from the mean. Next, we will discuss about correlation. Firstly, we will justify the correlation between dependent variable and independent variables. As we can identify the correlation between inflation, that is Y, and the three explanatory variables is more positive except GDP. We can interpret that inflation is positively correlated with money supply, that is 0.8575, as logically, the higher the money supply in the country can lead to higher inflation. It might happen if the money supply gets too large in relative to the size of the economy. Same goes to non-government ESP. The higher the expenditure of government can result in high inflation in a country, that is 0.0592, and it will make the non-government ESP positively correlated with inflation. Not only that, inflation is also negatively correlated with GDP based on the data that is negative 0.14833. We can interpret that the higher the gross domestic product, GDP, will make the inflation lower. It might happen sometimes when increase in inflation, the buying power of money declines, reducing consumption and thereby reducing GDP. Besides, if we compare the correlation among explanatory variables, money supply is negatively correlated with GDP, that is negative 0.04956. Meanwhile, money supply is positively correlated with non-government ESP, that is 0.18207. Next, GDP is negatively correlated with non-government ESP, that is negative 0.11111. From the result, we can see that the variables are mostly independent and not dependent to each other, as it does not have much positive correlation in the model except for money supply with GDP, but the magnitude is not too big. Hence, the multicollinearity in the model is almost not exist in this model when identifying the correlation, because usually high correlation between two or more independent variables is called multicollinearity. Okay, next we will discuss about variation inflation factors to prove that there is no multicollinearity in this model. So as we can see, the values of VIF for money supply is 1.0353, GDP is 1.04559, and non-government ASP is 1.013421. All of the explanatory variables is 1 and do not exceed to 2, since there is no variables with the highest centered VIF. Hence, we can conclude that the model is not suffering with multicollinearity problem. It means that the explanatory variable is not dependent to each other, and it will avoid the equation becomes biased. Furthermore, we can justify it by looking at the correlation, since it is already proven that the correlation between the explanatory variables is mostly negatively correlated to each other. Okay, after proving that there is no multicollinearity in the model, we can start to run simple linear regression of the dependent variable to estimate it using ONS estimation. Firstly, the regression that is involved is y that represent inflation against the first variable money soup that represent money supply growth. By using e-values, the coefficient r squared, standard error and much more data is calculated automatically. As stated above, the numbers of samples in this model is 62 chosen countries from all over the world, so the results are shown in the table on the screen. After that, we can insert the coefficient in the previous equation. So the equation is y is equal to negative 1.30585 plus 0.634987 money supply plus error term. As you can see, the sign of coefficient for money soup is positive. It indicates that the variables are directly or positively related. If money supply growth rate increases by 1%, the inflation rate will increase by 0.634987 percent points. As expected, the sign of slope coefficient should be positive, and it is shown in the model. Hence, it is true that the model is showing the expected sign for the model. Naturally, the multiple regression can be used to build better models so that we can predict the dependent variable better. Hence, we inserted two new variables, that is GDP and non-government ASP. By using e-views, the multiple regressions results are shown in the table. In the equation form, the multiple linear regression model is y is equal to 18.15395 plus 0.645825 money supply minus 0.351804 GDP minus 0.734543 non-government ASP plus error term. As shown above, the coefficient for money supply is positive, that is 0.645825. So the interpretation for this variable is when 1% change in money supply growth rate will result in increase of inflation rate by 0.645825 percentage points. Not only that, GDP has negative coefficient, that is negative 0.351804. It means that the increase of 1% point of GDP will decrease the inflation rate by 0.351804 percentage points. For the last variable, non-government ASP, the sign of the coefficient is negative 2, that is negative 0.734543. The interpretation for this variable is when the government expenditure increases by $1, the inflation rate will decrease 0.0073443 percentage points. Okay, next, when we add more factors that are useful for explaining dependent variable, the more variation in y can be explained, and it will produce better prediction. Hence, when we run multiple linear regression (MLR), the coefficient for the money supply will be different with the previous simple linear regression (SLR). When comparing the coefficient for money supply, the value from SLR is lower, that is 0.634987, compared to MLR, that is 0.645825. It is because the correlation might be the huge factors why the coefficient increases. So, besides, the next instruction is to discuss whether the model is suffering from omitted variables or not. Okay, so let's assume that the SLR is the equation for the model, and the omitted variables are GDP and non-government ASP, which is same as MLR. Hence, the equation should be y is equal to 18.154 plus 0.646 money supply minus 0.3518 GDP minus 0.7345 non-government ASP. However, we instead forgot to include GDP and non-government ASP, and the equation that we use to estimate is SLR only, that is y is equal to negative 1.3058 plus 0.634987 money supply. So as you can see, the estimated B1 for SLR is greater than 0, and we can conclude that money supply will increase inflation. On the other hand, the omitted variable in MLR equation, that is GDP, has the negative correlation with inflation, that is negative 0.14803. Not only that, GDP also has negative correlation with money supply, that is negative 0.04956. Hence, B1 should be suffer upward bias, but fortunately, the coefficient of B1 in the SLR is lower than B1 for MLR. Hence, the model is not suffering from omitted variables bias, even though our model is SLR only. When making the inferences, we need to conduct and test the hypothesis for all the variables to check the significance of them. By using e-values, we obtain the coefficients, standard error, and statistic value for all the variables. Hence, the information that we get is based on the table. Furthermore, the number of sample data for all the variables are 62. Hence, the degree of freedom which is usable for both one-sided and two-sided tests for the variable is 58. After this, I will conduct the one-sided hypothesis test and two-sided hypothesis test. Okay, firstly, we will start with one-sided hypothesis test. Based on the sample size, the chosen significance level is 90% and hence the alpha is equal to 0.1. So the results from one-sided test are shown in the table. So as we can see, since this statistic is equal to 13.385 for money supply that is greater than 3 critical 1.296, we will reject that hypothesis. So there is enough evidence to conclude that the money supply growth is statistically significant at 90% significance against one-sided hypothesis test. When comparing to its probability, it is proven that the money supply is statistically significant as the p-value is lower than alpha 0.1, that is 0. Furthermore, for GDP, this statistic is equal to negative 1.7022, which is lower than 3 critical negative 1.296, as we will also reject the hypothesis. So we conclude that the gross domestic product is statistically significant at 90% significance against one-sided hypothesis. When comparing to its probability, it is proven that GDP is statistically significant as the p-value is lower than alpha 0.1. Okay, besides, since this statistic is equal to negative 1.805 for long government SP and it is lower than 3 critical negative 1.296, as we will reject that hypothesis. So we conclude that the government expenditure is statistically significant at 90% significance against one-sided hypothesis test. When comparing to its probability, it is proven that long government SP is also statistically significant as the p-value is lower than alpha, that is 0.0761. Okay, after conducting one-sided test, we will conduct for two-sided tests at 90% significance level. As we know, the alpha is 0.1 and will become 0.05 because we made two-sided tests. Hence, the result after replacing the e-values are shown on the table. Okay, so since this statistic 13.385 for money supply and it is not between the two critical values, that is plus minus 1.672, so we reject the null hypothesis. So there is enough evidence to conclude that the money supply growth is statistically significant at 90% significance against two-sided hypothesis. Furthermore, for GDP, this statistic is equal to negative 1.7022, which is not in between the critical value that is plus minus 1.672. Hence, we reject null hypothesis as well. So there is enough evidence to conclude that the gross domestic product is statistically significant at 90% significance against one-sided hypothesis. Besides, since this statistic is equal to negative 1.805 for non-government ASP, and it is not in between the value for T critical 1.672 plus minus, so we reject the null hypothesis. So we conclude that the government expenditure is statistically significant at 90% against one-sided and two-sided hypothesis. In addition, to test whether all of the variables are jointly significant or not, the F statistic test is applied. So as stated above, the degree of freedom for the equation is 58. Hence, the F critical value is equal to 2.18. So it is shown that the F statistic is 60.73, which is greater than F critical value. Hence, we reject null hypothesis and we can conclude that the variables are jointly significant, statistically significant at 90% significance level. In summary, all of the explanatory variables are significant when testing it at one- and two-sided tests. Hence, we can conclude that money supply, GDP, and non-government ESP have significant effects on inflation at 90% significance level. Not only that, the explanatory variables are jointly significant at 90% significance level as well. Okay, in this subsection, we will analyze R squared to justify whether the independent variables together do a good job of explaining variation in the independent variables. As shown, the value of R squared is 0.7585, which shows that money supply, GDP, and non-government ESP explain about 75.85% of the variation in inflation. Hence, there's 24.15% is unexplained about the inflation. Consequently, the explanatory variables did a good job in explaining the variation in inflation since it has high R squared. Moreover, the F statistic value for this model is 6.736, which is significant. However, it is not always the case that high R squared are good for the regression model. The other factors of inflation can be included in the model is exchange rate, unemployment rate, and economic growth. Okay, quadratic function is one of the functions that are used quite often in applied economics to capture decreasing or increasing marginal effects. There are two methods we can test out whether we should include quadratic or not. Firstly, we can compare the graph for the regression. So based on the scatter plot, we can see that the data is not too spread out and not too many outliers. Not only that, the spread of the data in the graph is not mimicking the quadratic function. Hence, in this case, we can say that we do not need quadratic function in this regression because it is already okay. Okay, besides, the other method to identify whether the quadratic function is needed in our model is we need to test it out. So the chosen variable is government expenditure since we want to compare the effects of using two different functional forms. From the previous MLR, the equation that is used is y is equal to P0 plus P1 money soup plus P2 GPR plus P3 loan government SP, right? So since there is natural log function in the government expenditure in our previous equation, hence let's assume that the functional form is changing to quadratic function instead. So we get the new equation that is P0 plus P1 money soup plus P2 GDP plus P3 government ESP plus P4 government ESP squared. However, the result that we can obtain after regressing is shown in the table. As we can see, the adjusted R squared and R squared value for natural log functional form are so much better than quadratic functional form. So the adjusted R squared for log functional form is 0.756, while the quadratic functional form is 0.734912. So the natural log functional form is preferred than quadratic. Moreover, when testing the significance of the variables, we can see that the variables for government ESP and government ESP squared is not statistically significant at 90% significance level, and we decide to reject null hypothesis when we compare the probability for the two variables which is greater than its alpha, that is 0.05. So the probability of the variables government ESP and government ESP squared is 0.355 and 0.4717 respectively, and that's why we conclude that the two variables are not statistically significant. Then not only that, based on the graph above, we can prove that non-government ESP gives more better result as the data do not have many outliers compared to quadratic functional form. In summary, we can conclude that the natural log functional form is better and preferred compared to quadratic functional form. Not only that, if the data in the variable is big enough, it is better to use natural log function compared to quadratic. Hence, quadratic function is not needed to include in this model.